Hi there, welcome to this video on tangent and cotangent functions. We're going to look at some graphs of tangent and cotangent functions and see kind of how their graphs are manipulated by phase shift as well as period change, and specifically questions that appear on the AP test regarding their vertical asymptotes. Okay, so let's go ahead and jump in. We are learning to graph trigonometric functions, and you can identify period, phase shift for tangent and cotangent. You'll be successful. If you can identify vertical asymptotes for these functions, you'll be successful. And if you can graph some transformations of them, you'll also be successful. So we're going to go ahead and jump in. And the first function that I'm going to focus on is the tangent function. And what you should notice about the tangent function is that it looks different than sine and cosine. And that's because it is sine divided by cosine. And so kind of what happens when you have a function that's dividing is that value cannot equal 0. If it is, you get vertical asymptotes. You get a discontinuity, vertical asymptotes. So when my cosine function, the denominator of tangent, is equal to 0, then we're going to have asymptotes. And that happens at our north pole and our south pole, 3 pi over 2, as well as in the negative direction, right? So negative pi halves, and then as well as negative 3 pi over 2. So those are where your asymptotes are. And a tangent function really kind of looks like a cubic function, y equals x cubed. It's centered at 0. It's an increasing function. And the other two key points we really use to help graph us is pi force, negative pi force, negative 1, and positive pi force, positive 1. And that's pretty easy, right? Those are pretty easy values to remember. At pi force, your sine and cosine values are the same. So you get 1, okay? And so that's what our graph kind of looks like. And for our sakes and purposes, as far as graphing this, the center of the graph, what you need to remember where you kind of start with this function is 0, 0. So our graph is centered here. Now this won't be the same for cotangent, so just it's important to note this. We're at 0, 0 is our center, okay? And so I wanted to show you on Desmos, here is you know, our graph of tangent, and I just wanted to kind of walk you through. So what happens if I have a period change that extends the period? And by the way, now that we're talking about period, notice how long until we repeat. Asymptote to asymptote is only pi, negative 1/2 of pi, and another positive 1/2 of pi, which makes 1 full pi. Not 2 pi like sine and cosine, so it's different. The period is pi, very important to remember, divided by b. So what happens if my b value is 1/2? Well, then our period is going to double, right? Because you multiply by the reciprocal of that. And so here's what it kind of looks like, right? If we extend this. So notice, again, my center of my graph is centered at 0, and my asymptotes kick outwards. Okay, so instead of being at negative pi halves, well, they double, right? That distance doubles. So now my asymptote's at negative pi and positive pi. And then our other points also will double, okay? So that's kind of what happens, and then the same thing if we compress. So I just wanted to kind of give you that visual of how this graph is centered, right? And then if we have phase shift, so we will shift our central point, and then again, that central point is the center of your period, right? So divide your period by 2 and go go out. So we'll go ahead and graph some of those and hopefully make it clearer, okay? So let's jump in. Again, here's kind of the format of tangent. Your A value is amplitude. We won't really see that in this lesson, but that would just kind of stretch your graph. You'll period change, B, we'll definitely see this, and then C is your phase shift. Remember, it's always the opposite value, okay? So let's go ahead and graph example number 1 here. They say find the period and the phase shift, then graph at least 2 cycles of the function g of x equals tan of x plus pi force. Okay, so the very first thing is that our period is pi divided by the absolute value of b, which in this case our b value is 1. I have it, but it's trivial. It doesn't do anything. So our period's pi, so no effect there. But we do have a phase shift. Our phase shift is going to be negative pi force, because that's our C value, okay? So my graph, I'm going to go ahead and graph the center of my graph. I'm going left pi force. So here is my center. And then my period is pi, And if you're confused about, you know, how much is pi? Where are my asymptotes going to go? Just look at your grid and then kind of count. Look, 1, 2, 3, 4. So that's pi. So 4 units is pi. So if this is the center, I should go 2 this way, right? I'm going to have an asymptote here at -3/4 pi. I shifted left one unit, right, on this graph. So from my asymptote at -pi/2, I just shift that left one as well. Okay, and then this one, kind of the same logic, right? I can go right 2 units, or half a pi would be that distance, or if you know where your asymptote starts, and then you go this way. So here is the center of my graph. Here's my asymptotes based upon the period, and then our other key points, right, are going to be the pi force -1. So negative pi force -1, and positive pi force right, +1, right? So from your origin, and I kind of like to make a a table. So here is x, here is y, or g of x. Okay, so 0, 0 is your center, and then I go left pi force down 1, and right pi force up 1. Okay, so those are your key points. And this graph is increasing. So from your asymptotes, kind of curve, and then up towards the other asymptote. Concave down in this section, and then concave up through that section, okay? So there's one example. Now let's look at an example where we have a period change. So check out this one. Notice how b is equal to 2. So my period is going to be pi divided by 2. Okay, so my graph is getting compressed, right? So phase shift, I'm going left pi/2. Okay. So I am going to go ahead and do my phase shift first. So I'm going left pi/2. So right here is my center. And then I need a period of pi/2. So if I take, pi/2 and I cut this in half, I divide it by 2 again, that's pi/4. So I'm going to go left pi/4, all right, which is just 1 unit. Okay, and there's an asymptote. And then right pi/4. And then there's an asymptote. Okay, so there's my asymptotes. I shifted left, and again, my period is based upon my my center there, right, which is that point. Okay, the other key points, I'm just going to kind of split this distance. So left, I guess it'd be pi/8 now, right pi/8 up 1, and here's our graph. Whoop, there you go. Okay. I forgot to talk about this in the last example. I guess I can throw it back in. But this is going to repeat. So, up here in this example, up here, my asymptotes are going to repeat every pi. So I could go ahead and graph 1, 2, 3, 4, and then all of a sudden now I have, another cycle of this graph, right here and here. And so I have another graph this way. And I could complete this again. Go another 1, 2, 3, 4. Okay. And then these asymptotes will repeat. So they are cyclical. They are periodic. You are going to, repeat this over and over and over again, all the way left and right. Okay. So, here are asymptotes, right? We have asymptotes at x equals pi/4 plus every pi times k, where k is an integer. K is an integer. Okay, so if we see a question like that, that's kind of what happens. And then down here, it's every pi/2 all have another asymptote. Okay, so here is again the center of my graph, and then, wait, what am I doing? That's way too high. Here and here. Okay, and so here's our graph. Boop. Okay, as far as how many of these do we have to graph, ask your teacher. Sometimes, usually, like 2 cycles is good enough if you graph 2 of them. Sometimes your teacher will want you to graph all the way left and right. So based upon your teacher, if you're hand graphing these, listen to your teacher. But what I think is important here, because on the AP test you don't have to graph these. That's not one of the topics assessed. It's kind of where is your asymptote? So for this one, I have one at pi fourths, or I could say, you know, negative 3 pi fourths plus the period. So plus every pi halves times k, again where k is an integer, and I'll use some mathematical symbols there. That means k is an integer. K is a part, that's what this means, is an element of, and then this is the symbol z for integers. All right, here's a practice problem. Please go ahead. I want you to pause me, try this one, and then we'll see if you got it right. Okay, so let's look at one cycle of this tangent function. Your b value is 1/2, so your period is actually getting stretched by a factor of 2. So 2 pi now, and your phase shift is right pi halves. So you do your phase shift first, and then you're going to plot your asymptotes based upon your period. So I go right pi halves, you can see that here, and then my period is 2 pi. So I went pi this direction and pi this direction, and then I have my key points, which kind of split the difference again, right? So if this distance was originally pi fourths, I multiply that by 2. So now it's pi halves this way, down 1, pi halves this way, up 1. Okay, so that's what one cycle looks like. Let's go ahead and add a second cycle. Okay, and here you go. There is a couple more cycles of how this graph looks like. Okay, important to note, asymptotes are going to be at negative pi halves plus 2 pi k, or 3 pi halves plus 2 pi k. So they'll repeat with the period, with more asymptotes. So let's look at an example kind of this that appears on the multiple choice test for the AP calculus exam. The function f is given by f of x equals 2 tan 1/2 of x minus 3 pi halves minus 1. Which of the following gives the period and 2 asymptotes of the function? So your period is going to be pi divided by b. So pi divided by b, and our b value is 1/2. So again, we kind of just saw this. Our period here is going to be 2 pi. So I can throw out a and c, and then where the heck are my asymptotes? Well, we do have a phase shift. So c is equal to 3 pi halves. So I'm going right 3 pi halves. So definitely, it looks like b is going to skip it. So answer is going to be, oh wait, no, I got it wrong, guys. The center of my graph is at 3 pi halves. And then since our period is 2 pi, right, if I'm sketching this, here's 3 pi halves. Okay, I go this way. Here's my center of my graph. I go this way, pi. And so I'll have asymptotes at 5 pi halves. And I'll go pi this way. And so at positive pi halves. Answer is B. It is not D. That's the center of your graph for tangent. My bad. Hopefully you got me. Okay. Practice problem here. The function d is given by d of x equals 3 tan of 2 pi of x minus 3. Which of the following is the period of d? Hopefully you can figure that out. Pi divided by b. Pi's cancel, you get 1/2. Watch out for that invisible 1 in the numerator. Answer is A. Okay, so that is tangent. That's how you graph the tangent function. What about cotangent? So I want to look at cotangent, and cotangent looks very, very similar. Hopefully you noticed that it looks like a cubic function. We have asymptotes, the period from 0 to pi, so our period is pi. So, you know, it looks very, very similar. What's different? Well, what's different is that it's a decreasing function. So notice tangent's increasing, it goes up from left to right. Cotangent goes down from left to right. Also, where our asymptotes are at are different from cotangent. Cotangent is cosine divided by sine. So since we're dividing by sine, whenever sine of x equals 0, cotangent is going to be undefined, and that's where our asymptotes are. So that will happen at 0, it will happen at pi, it will happen at 2 pi, okay? And so that is, you know, where our asymptotes are for cotangent. Again, what's kind of important for cotangent, when we graph cotangent, is the center of our graph is again going to be 0. which this time is not the center of our graph. It's actually our left asymptote if you're graphing the first cycle. So always plot your asymptote first and then use your your period to graph the rest of it. Okay, so if I have a phase shift, I'm going to use my phase shift and plot my asymptote. Then I'll plot the rest of my function. So it's different. And I want you to see kind of how that is different here on Desmos. So let me turn on the cotangent function. So here's our cotangent function. And watch this asymptote. Let me, I don't know if I can change it. Can I change that one? This one? Let's make it purple. Oh, wrong one. Let's go down here, this one. Let's make this purple. Okay, so watch what happens if I move my graph left or right. Okay, let's say negative pi halves right there. And then I'm going to turn on a phase shift. And I want you to watch what happens is that this will stay put. At least it should. Oh no, it's not staying put. I think I have it done wrong. It should stay put. And then, this will stretch out. Okay, I went ahead and fixed the parameters here. So let's try. Let me do this again. So let's say I have a phase shift. Let me go left pi. We'll go left pi. So our graph is centered at pi. Again, you're going to center with an asymptote. Okay, let me type negative pi here. And then say I have a stretch. Watch how this graph stretches, how pi does not change. So your first asymptote will always be your central kind of like anchor part of your graph. All right. So let's go ahead. Let's graph some of these guys and then see what we get here. Okay. So example 1. What is the period in phase shift for cotangent of x minus 3 pi over 2. Our period is going to be pi divided by b. Again, in this case, it's just 1, so period is pi. But I do have a phase shift. I'm going right 3 pi over 2. So 3 pi over 2, and for cotangent, we graph our asymptote first, and our period is pi. So pi later be 5 pi over 2. That is going to be our second asymptote. And then our graph is kind of centered in there. So I'll be centered right in the middle. And then left pi force up 1, right pi force down 1 are our key points. Okay, so it reverses, right, from tangent. And then our graph is a decreasing function. So I'll start close to this asymptote, I'll curl down, concave up, and then our graph turns and goes concave down. Okay, and I can graph another cycle of this, so just 1 pi later, I have another asymptote, and then again our graph is, centered at the same spot. Okay, all right, so there's a rough sketch of example 1. Here is example number 2. Now I have a b value in this one. That is 1/4. So my period is going to be pi divided by 1/4, which gives me 4 pi as my period. Oh my gosh. And I have a c value, which is negative pi halves. So I'm going left pi over 2. Okay. And that's going to be my first asymptote here. 1, 2, 3, 4, 5, 6, 7, 8. There is my shift for cotangent. Okay. And then 4 pi. Oh my gosh, I made things really hard on myself. Well, if it was at 0, 4 pi would be there. So I went left, what? Pi halves. So that's going to be 7 pi over 2. Okay. And smack dab in the middle would be 2 pi shifted left. So that's like 3 pi over 2. Oh wait, what am I doing? Here. Whoop. There's our center. And then halfway is going to be our other key point, up 1, and then the other direction, halfway down 1. So, whoa, this graph, oh my gosh. Okay, so there's a cotangent function, okay? And again, you could graph another cycle in that direction, kind of the same idea, all right? So, anyway, that's kind of how cotangent function behaves. It'll be centered at your left asymptote. Okay, so please go ahead, pause me. I want you to try this graphing one here. Okay, here is the very first cycle. You have a phase shift of pi force right, so your asymptote should be right pi force, and then your period is pi divided by 2. So cut that, period in half. That's why you see it kind of compressed. And then we'll be centered in that distance, right? So I went from my left asymptote of pi fourths, I went right pi halves, and there's my other one. And then so in the center is my key point, and then my other two key points are smack dab in between my central point and then the asymptote, okay? And again, we can graph another, you know, period of this, centered here, halfway at 1, halfway at -1, and then here's our curve, okay? So there's a rough sketch of cotangent. Hopefully you got that. All right, let's close out this lesson. Here's a couple of practice problems about vertical asymptotes. So they say, which of the following functions has a vertical asymptote at theta equals pi fourths? Please pause me. Try this one. Okay, hopefully you got C, and the trick here is to know your period. Your period is pi. So if my vertical asymptote, my first one here, is at -3 pi fourths, I'm adding pi to that, which gives me 1 pi fourths, okay? If I went with this pi fourths, if my C value here is -pi fourths, I'm moving left pi fourths. My other one's going to be +3 pi fourths, right? You have a period of 1 pi. For this one, here again, it's going to be -pi halves, +pi halves. That's not the way. And then right here, your first one is going to be 3 pi halves, and then right pi would be 5 pi halves. Okay, so answer C on that one. All right, last practice problem here. The function g is given by g of x equals tan of 2 pi x. Which of the following statements about the graph of g in the xy plane is true? Vertical asymptotes occur at, where do they occur? Go ahead, pause me, try this one, and then we'll go ahead and look at the answers. Okay, hopefully you got B here. For this one, first of all, you have to notice that this is a tangent function, so it's different than cotangent, what we've been looking for. Hopefully you caught that trick. Your period is 1/2. Period's 1/2. So I don't have any phase shift, so if I did a rough sketch, I'm going to be centered at the origin, and then my period is 1/2. So I'm going to have an asymptote at 1/4 and 1/4 in the negative direction, right? Because that has to add up to 1/2. So we have an asymptote at +1/4, and then I'm going to add an asymptote every 1/2 period. So 1/2 times k, where k is an integer, okay? All right, in this video, we went ahead and covered the sine, or sorry, not the sine, the tangent and cotangent functions, what they look like. They look like cubic functions. Tangent's increasing, cotangent is decreasing, and they both have asymptotes with periods of pi. That's the main difference. Hopefully you learned something. Give this video a thumbs up. I'll see you in the next video.